Hey guys, welcome back. I am Mr. Anthony Weinkopff with Embrace Tutoring and Educational Services. It's good to kind of be back again. Today we sort of have a very special topic to cover. Many of you would like to go over the recent March SAT that they just released in 2020. Obviously, we're going to start with section 3. We're going to purposely get through as much as we can. I would always encourage you, if you have any ongoing questions, to simply just put the information within the chat feature. So that way we simply put your questions within the chat feature, as well as any hyperlinks or anything else I can provide you. So make sure you stay tuned for future webinars so that way you guys have everything you need, okay? So we're gonna get ready to jump into it. And once again, we're gonna be doing the March 2020 SAT practice test for those of you that are just joining us. So this is what the test is essentially gonna look like. And it's very similar. So the style and format is always essentially the same. It even actually works off of this book here, right? So that way you guys can see it for the College Board, the SAT Blue Book, right? Of kind of what to anticipate. We're not going to need a calculator for majority of this. I may use a calculator just to sort of like speed things up a little bit for doing some general things. But for the most part, most of everything is being able to be solved through like a basic strategy of identifying what the given is and making appropriate estimations and such. But if you do need a calculator for whatever reason, if we move into section 4, right, you want to sort of take a screenshot of the problem and attempt these problems independently, which is something I would definitely recommend, then just something as much as like I would say like a TI-30X or TI-84, if you guys have a graphing, that's completely fine. Just make sure you have it available. Okay, so we're going to move in and sort of get started. So here it is, the SAT question and answer service, right, in terms of the full test for what was released. Also have to be honest with you guys, I didn't go through and do every single problem on this test. Definitely not in section 3, because the reason is I wanted to look at it sort of like in live time to sort of tell you what I see. So I simply just glanced at a few of the problems, but I just to sort of just get a general framework if there are any types of problems that are very uncommon to previous SATs to sort of get a general idea. But for the most part, I would say 90% of the problems are kind of what to expect, right? They're kind of what we've been covering thus far. And the reason I didn't sort of like go through every single problem is purposely so I can walk you through kind of what's the most efficient strategy, like on the spot, so you guys can see in real time of like what I'm thinking about and how I'm analyzing the problem and what's going to be the best course of action in order to tackle that particular problem. Get started. Math test, no calculator section, 25 minutes, 20 questions. The general directions I'm not going to read because I expect you guys to be able to know that. The calculator is obviously not permitted. Here's the general reference section that they provide me. You need to know these things. Don't just assume they're kind of going to give it to you, because more importantly, you need to know how, when you're reading a problem, how that's essentially a tool and like what you're going to use them for, right? You need to know how to use them more than just what they are. That's probably the biggest piece of advice I can give you, general application. So here we are, we're going to move into number 1. I'm going to zoom in as well for some of these particular problems so it's a little easier. And because I know this is the first time many of you are ever seeing these problems, I will also take a minute to sort of read the entire problem so you see it, and then I will tell you sort of what I'm thinking about, and then I'll quickly solve it, right, as we kind of go through. Now, do remember that as you go through the SAT in general, the test gets gradually harder. So my goal is to really kind of, in real life, if I was doing these problems on an actual test day, my goal is to get through as many of these problems as I can within, I would say, the first 50% of problems I should do probably within the first like 25% of time. So I really don't want to write too much when I'm doing these particular problems. I want to see if I can solve probably questions I would say like 1 through 5 or 1 through 10 as much as possible, like in my head, or very minimal writing, very minimal calculations. All right, so the question here states, the table above shows some values of x. Notice I immediately skip the table, right? I don't need that until I figure out what I need to solve. It says, which of the following equations shows a possible relationship between x and y? So the word relationship is hinting at the fact that I'm going to have some sort of equation. This is also signifying that I might have like some sort of slope, right? That's corresponding to it. And what I want to do is I want to skim down and I want to look at my answer choices relatively fast. And this all says y equals, y equals, y equals, y equals. And then I go back up to my chart, and my chart here says x is -1, 1, right? When y, so when x is -1, y equals 1. When x is 0, y equals 2. When x is 1, y equals 3, etc. And the easiest one for me to use always is the 0. So I'm purposely going to go to the 0 because now if I plug 0 in, it's less calculations I essentially have to do. So here I do y equals, and I'm going to put 0 in, right, to save some time, plus 2. So if I plug this in here, y should be 2, right? That's where this 2 is coming from. So it should be 2 equals 0 plus 2. That does work. So this a still works, which means if I move down, b won't work, right? If I plug 0 in here, that'd be -2. If I plug 0 in here, that'd be 3, right? Notice I'm doing a lot of this in my head. It's only question 1, right? I'm not going to write a ton down. And then here is -2. So actually A is our answer. But if in the instance where you ever get stuck, go on to the next, right? Go and check the next value. That way it makes sense for you. So if I plug in 1 here, right? And then this becomes 1 plus 2, this becomes then 3. So that does work. So because it works for multiple values and none of the other ones do work, I'm definitely feeling confident that A is my best answer, okay? Now, sliding over, I see, and I'll put it in a different ink so you guys can see it. Here I have 2, and for question 2, I see J, K, I see L, M. These look parallel, right? That's usually the setup. And it says, in the figure shown, J is parallel to line K. So whenever you see something along this wording, right, and you have what are called, these are called transversals, right? And it says L is parallel to M. So whenever you have transversals that are cutting through, then you have to remember all of your geometry rules. And really what they're telling you are, in a very quick nutshell, we're not going to go over every single geometry rule, but basically it's sort of, they're giving you information so you can identify like a proof, right? So everything you learned in geometry, all in like 10th or 9th grade or whenever you took geometry, everything you've ever learned is basically summarized on like one question. So essentially what's happening is that they say, what is the value of x? So I want to go and I want to circle x because now I need to figure out what other information do they give me that's relevant in order to me solving specifically for x. I know that because this is 80 degrees here, I know that this is also 80 degrees. That's called vertical angles, right, in terms of my geometry principle. I also could theoretically solve and say, because this is 40 and this is 80, then this is going to be the last bit of 80. So this is going to be, right, 40 plus 80 is 120. So that means that this then is going to be 60. That's if I needed to solve for that angle as well. I don't. The reason I'm doing this quickly is so that way you guys can see like general review of what it looks like, right? This is a linear angle for 180. Now, what they do give me though is the fact that they're parallel lines. And if these are parallel lines, then what I have here, given the fact, like if you remember, there's a Z formation, which you refer to as alternate interior angles. So because of the fact that these lines are parallel, this up here is also 40, right? And because now these lines are parallel between J and K, and this being my transversal, it means that this will also be 40, right? And technically, I want to say, I don't remember whether the technical term is corresponding or something or alternate exterior, but essentially it means that these two angles here, right, this angle and this angle are going to be congruent. So 40 will equal X, which means my answer is also A. But if you get stumped on how to do this problem relatively quickly, I would say go back and look at your geometry rules and your geometry principles, because that will teach you very quickly kind of how to identify these things. And I can do this problem relatively quickly because of alternate interior angles. I know vertical angles. I could even use, right, some of a triangle here if necessary, but and then these I believe are called corresponding angles. So there we are. That's question 2. Okay. Now going down to question 3, looks like it's here. Looks like it's standard function. It says, what is the value of f of 4? If I plug this in, I'll put it over here so you guys can see it. Now remember, whenever I have just standard functions, and you would refer to this as functions and substitution, and it says, what is the value of f of 4? I simply need to plug this in, right? That's my input. So it's basically saying when 4 is x, and once again, hopefully you can do majority of this in your head, so you're really not writing any of this down. I'm just showing you essentially what we're happening here. This becomes 4 squared minus 5 times 4 plus 6. This is now just standard order of operations, right, or PEMDAS. right? And so this becomes 16 minus 20. Make sure to multiply this before doing anything else. And then plus 6. I'm going to take my like terms, my positive like terms first to make it easier. So then 22, and then I'm going to take my other negative like terms. So my answer should be 2 overall. B should be my answer. All right. But remember, for functions and substitution, that's how we generally refer to this. It means that whatever your x value is here, we're simply going to plug that into the rest of the equation, right? That's as hard as the problem gets. So B should be my answer. All right. So number 3, Racely, okay, can spend up to $20 on streamers. I'm also going to circle this up to a total, and then I'm going to go down and skim my answer choices. I notice that I have inequalities here. And because I have inequalities, right, inequalities, it says up to $20. So that means at most, right? So it means I cannot exceed $20. So everything on this side of the expression, right, needs to be less than $20, right? So $20 is the most that I can spend. So that means that anything where this is like greater than $20, I'm immediately getting rid of that. So as I'm reading the problem, I'm interpreting it, and I immediately start cutting answer choices off. I don't know anything other than up to at most $20, and I'm immediately down 50% of the answer choices. All right, it says on streamers and balloons for a party, streamers cost 1. So here I have 1.49 S, right? And then obviously it's going to be, the balloons are probably going to be 4.39 B, right? Which of the following inequalities represents a situation where S is the number of packs of streamers can buy and B is the number of pack of balloons can buy? So notice what they're doing here is that they're just referring to the plus. So it's just referring to the total. So it's the total of streamers and balloons. So B is going to be my answer choice, okay? Now let's slide down to number 5. And you tell me what you essentially see as we're going through this. So Bill is planning to drive 1,000 miles to visit his family. So it seems like it's 1,000 miles total. If he plans to drive 250 miles per day, which of the following represents the remaining distance? Now, here's one thing you want to immediately note. So this is the total. This is what he starts with, right? This is his initial value. And then it says if he plans to drive 250 miles per day. So the 250 miles per day is a rate, right? So if that's what I want you to sort of hang on to so you can kind of understand that. And then it says, which of the following represents the remaining distance? Well, distance is what miles is, right? So that's going to be, so D here is going to be equivalent to the same unit. So D is in miles, and I start with 1,000, and the word remaining, right, which is the following remaining distance means that he's been driving, right? He's been driving, he's been going to see, so in miles that would give, have to drive to reach his family after driving for n days. Well, n days means that it should be multiplied by the 250 miles per day, because then these will cancel, almost like unit conversion. So this is going to be, the minus is what signifies remaining. And then it's going to be 250, and it's really 250 miles per day. So I could even put it like this. And then I'm going to times n days like this. And then these will cancel. So D is going to be my best answer choice, right? Based off of what my initial is, and then lining up my units in terms of what the rate is, right? So 5 is going to be D. So let's move to question 6, and it says, which of the following is equivalent to the given expression? Now, for this particular question, it just looks like you're combining like terms, right? You're simplifying or you're combining like terms. And I would say the most common mistake is if there is a negative sign here, you forget to distribute the negative sign, and then you get incorrect like terms. But because of the fact that this is a positive sign, I'm just going to take these values here out of the parenthesis, and I get x to the third plus x squared minus x. And yep, don't overthink this, right? These are all different, right? This is a different like term. This is a different like term because it's x to the third. And this is the only other similar like term. So here I have x and a minus x. These go away. They are like terms. The others are not like terms. So x to the third plus x squared, that cannot be simplified. So that is your answer, right? So x to the third plus x squared. Just pay attention to, if you have a question like this, right, without overthinking it, just pay attention to whether or not there's a negative sign here, because if there is a negative, then you have to distribute it into what's inside of the parentheses, and then that is where you can sort of make little mistakes. But remember, we're only on question 6, so the questions are still relatively straightforward thus far, right? Question 7 is getting a little bit more complicated. It seems like there's some functions that are being thrown in here. First of all, I want to skip this until I know what they're asking for. And then it says the table gives some values of x and the corresponding values of f of x for the polynomial. Whenever I see x and f of x, I'm immediately thinking y and x or x and y, which is fine, could be the graph. So could be the graph of f in the xy plane. Now, remember, no calculator section. So first thing you want to do and you want to target is usually the 0, okay? So I want to go and I want to figure out when x is 0, y is 2, okay? So I'm going to go and plot. And one quick tip, pay attention to the increments, pay attention to the units that they have so you don't make a common mistake right here. Because notice that these are 7s, 2s, 3s, etc., but these are 10s, right? And it doesn't look like there's 10 over, they're 5 over. So that means that every one of these lines here is an increment of 2, right? So pay attention to that so you don't make a common mistake. And you also want to quickly, just to make sure you don't make a common mistake, is you want to make sure that all of them fall in the same same schematic, essentially, and they do. All of them do have 10 within the units, and they all do increments of 2, and they all go up to 10, right? And they're not going to go any further than that. So the scales are essentially uniform, right? And I want to just pay attention to that quickly, so I don't have to sort of keep doing it. So this is 0, 2, and I want to plot this, which means when x is 0. Here, y is 2. So that's my point here. When x is 0, y is 2. So that's my point there, right? And then let's slide down. I'm actually going to make this a little bit smaller so that way we can do all of them at once, if possible. Nope, it's not allowing me to do that. Okay, hold on. Let's zoom out. And here we are. Okay, just so you guys can see it. So I know the 0, 2 thus far is here. 0, 2, 0, 2. Remember, when we're doing, it's this. So it's over 0, up 2, essentially. Just a quick reminder. And that's not it here. So C is out, right? But I can check C just in case with another value, just in case. And then this is out. Or this is good thus far. All right, now I'm going to slide back up. And I am going to purposely do the furthest ends. So I'm purposely going to do the furthest ends so that way it makes it easier. But I know this is a 30. Right, and 30 is not pictured here, so I'm probably even going to avoid that, and I'm probably going to choose the 1, 7. So this is -2, -2. So now I'm going to slide down again. Here you are. This is definitely a lot easier to do on the actual test day because you have everything on the same page and you're not going back and forth, right? To kind of make it a little bit easier on yourself. So I am doing -2, -2, and this is off position. Right, here we go. So for -2, -2, it means that I want to go over -2 and I want to go down -2. So that's sort of my point here, knowing that these are increments of 2, okay? So I would go back, right, for -2, back like this, and then down, right, for the other -2. So it means it would be here, which it is not. So I'm not leaning towards A. For here, it does sort of look like it could be, right? And then for here, it definitely looks like it crosses, right? So I'm actually leaning towards D. I like D the best, but maybe I'll go and I'll check like one particular value or one other value just to make sure as I'm looking, because right, arguably you might be able to make a case here. So let's go to another value as well. Actually, hold on. You could do here, right? But I've already sort of gotten rid of C, so I'm liking D the best still. I'm gonna do one more value. Let's do 1, 7, okay? Because that's an odd value given the fact that these are all in increments of 2. So 1, 7 would mean I'm going over 1 and I'm going up 7, right, to quickly count. So here's over 1, technically it's in the middle, and then up 7. Okay, so here's the 2, the 4, the 6. Yep, that's about that. Yeah, so I like D the best. So I'm gonna choose D in terms of time. So for number 8, it says here, which of the following expressions is equivalent to the given expression where x does not equal negative? Because of the fact that I have variables here, and because of the fact that I have variables here, I have given you guys the tip that you could essentially choose a number, okay? and you could choose a number to match. And if you were going to plug in a number, then simply essentially plug in that number, right? So let's say I plug in x equals 1, then this up top here becomes 3, then this becomes 3 squared, right? So 3 over, right? If you can sort of see what's going to happen here, though, is that this becomes 3 over 9, which becomes 1/3. I then plug 1 into these. So it's not going to be a, right? Because 1 plus this should be 3, right? Notice I'm checking my numbers between both. It's probably going to be b, right? So if I do b, which is 1/3, right? 1/3. Yep, that's too high. That's too high. Yeah, so b. All right, so now here's the other classic way of sort of identifying this problem relatively quickly. If what you want to do is, it could help if you expand this out, where it's like x plus 2 over x plus 2 times x plus 2, right? Because here if I have the square. So just like this format up here, where you have like 3 over 3 squared, right? It's the same kind of mathematical identity. So if you have trouble with doing this, you're going to have trouble with doing this as well, and you'll eventually just solve, right? That's why I'm saying choosing a number is sort of always a default way if you get stuck with something with which of the following is equivalent. But mathematically, if I have x plus 2 over x plus 2 over x plus 2, this then becomes 1 over x plus 2. So there's 2 quick ways of solving the answer. I get b for both, so I know that's definitely right. And I'm going to move on to number 9. All right? So number 9 says and states, which of the following is an equation of the line? So whenever I see this, this equation of the line xy that contains points 1, 3, and it contains points 5, 15, and I skim my answer choices, and my answer choices are all in like a y equals mx plus b, right? As I'm looking here, and because all of these are in some sort of y equals mx plus b, the thing that I noticed that I can derive. So now the question is, what can I derive from the information that they give me, right? That's what I'm trying. What can I derive from here that I can somehow use to answer this question? Because you may not be able to actually get the intercepts, right, or the y-intercepts, right? But what you can get is the slope. Because if I give you 2 points and you're assuming that all of these answers are in a linear fashion, you're just assuming the line is going to be linear. And if you're assuming the line is linear, then it just becomes a y2 minus y1 over an x2 minus x1. And what you're attempting to do is you're trying to solve for the slope, right? Because the slope of the line is what is different between all 4 of these given answers, right? All 4 of the given equations. So here I'm going to do 15 minus 3, right? Which is my y2 minus my y1. And then I'm going to do 5 minus 1. And then so this is going to be 12 over 4, which will give me 3 over 1. So my answer should be, the only one with a possible slope of 3 is A, right? So that's works. So A is going to be my answer of how I go through and solve this. But remember, it's always a matter of what do they give you, and then how can you relate it to the given problem. So I'm sure there's other ways to do this particular problem, but I can do this problem without writing a lot down. I can even do 15 minus 3 in my head, right? And then 5 minus 1 in my head, and then sort of simplify and write a few things down if I need to. But the reason why I did this was because the slopes are different between all 4 of the different answer choices, and that was the best method for me anyway in order to solve the problem. Okay, so let's slide down. All right, so notice the questions are going to get a little bit more advanced now, right? They're going to give you like larger geometric figures. They're going to start saying infinitely many solutions. It's going to get a little bit more complicated. They're going to throw some radicals in there. So be prepared for like the second half, for 10 out of 20, to make sure that you're checking your answer and you're sort of not rushing too much where you have a fairly solid foundation, okay? So this is 4x plus b over 2 equals 2x plus 8. Now I want to figure out what I need to find. It says what is b, but it says in the given equation, b is a constant if the equation has infinitely many solutions, which means I need to make this equation the same. Okay, so I need to sort of analyze what do I need to do to this in order to make it the same on both sides. Well, what I see is I have a 4x plus b on this side, and if I take this 2 and essentially cross multiply it, where I bring the 2 up, right? So here I have 4x plus b, but then I'm going to bring the 2 up to cross multiply, and what I'm going to end up getting is another 4b, or I'm sorry, another 4x. And if I get another 4x, then the only difference between the equations is my 16 and my b, right? Because when I distribute this becomes 16. So the 4x's kind of like cancel almost. And if they didn't cancel, you need to figure out a way to make them cancel. That's the idea of making it infinitely many solutions, is that you need both sides of the equations to equal, right? In order for them to be infinitely many. So I need to figure out a way to make the equations equal on both sides in order for me to get infinitely many solutions. And so B is going to be 16. So D is my answer. Really not that tough of a problem if you sort of see it and you know what to look for. Pretty tough, and you'll mess around with a bunch if you don't see it and you don't know what to do. All right. So number 11. What is the area in square units of the figure shown? So here's two things I immediately take away, is that if I draw this little line here, I have a triangle. So quick note, whenever you have a figure, maybe even like a parallelogram, trapezoid, whatever it is, really what they want you to do is they want you to draw triangles. That's the idea. SAT loves triangles, probably more than anything else, because there's like different styles, triangles in some version of a circle, but they love triangles. So here's now what I have, and I'm gonna I normally wouldn't redraw all this on the test, but I'm just gonna do it so you can see it. So here's 4, here's 4, here's 4, because the fact that it says a square, so it's equal on all 4 sides, okay? So 4, 4, 4, 4, and then here I have a 5, and this would be a 3. Now, if you don't remember that this is a 4, either because of the square, you could theoretically solve, right, or remember that it's a 3, 4, 5 triangle, okay, because of special right triangles. And if you can't do that, and maybe you forget that too, then you could use Pythagorean theorem, right? So there's lots of different ways to do this, right? But hopefully you recognize, because of the fact that it's a square, they're equivalent on all 4 sides. So this says, what is the area? Now, I don't want to take for granted. So as I read this, I normally always want to write down, okay, A equals for this, which is going to be for the square, but I also want to record A equals 1/2 times base times height, right? For my triangle. So my square is relatively easy, right? This is going to be 4 times 4, which is 16, right? 4 times 4 in order to get my area here, which means anything less than 16 is not going to be an answer. Nope, they didn't do that to you, but just keep in mind, if you could start using cross elimination. My area here is 1/2, and my base will make that 3, right? And my height will make that 4. So this is going to be 12 times 1/2, which is 6. So area equals 6. But notice it says, what is the total area of everything? So my area here is 6, and my area here is 16. So my total area is going to be 22. B is my answer. Move on. Yeah. Quick tip. Whenever you have the area, right, pay attention if it's square, triangle, etc., and then always pay attention to the triangle formula of the triangle, right? You're basically trying to figure out and how to form triangles within an answer. And because of the fact that this isn't drawn initially, that is sort of the difficult part. The moment you draw that, it makes it a lot easier in order to see the problem. But that's exactly why they don't draw it for you. It's because they're seeing if you know kind of what to look for in terms of the triangles. Question 12, it says, what is the y-intercept? When the moment I see y-intercept, it means where x equals 0, okay? And I'm immediately labeling that down to make it a little easier. So what is the y-intercept of the graph of y equals 4 of x in the xy plane? Well, here's a quick thing. There's only one answer choice where x equals 0, so it's probably going to be this particular answer choice. But I'll plug it in anyway, just so you can see. So y is going to equal 4 to the power of 0, which yes. So when x equals 0, then y in this case will be 1. Well, y is y1 because anything to the 0 power becomes 1. So that's a quick tip I would give you. So C is going to be my answer. Okay. For question 13. Says, what is the sum of the solutions, right, to the given equation? Here's one thing I notice. I have some sort of like quadratic, it almost appears, right? Remember, because whenever I have ax squared plus bx plus c equals 0, this here can then factor into other kind of other parts. And if it could factor into other parts, then these could be solutions and I can simply add them, right? So that's really what they're asking is, can you readily identify that if I factor this, I can have potential solutions? Now, I want to get this into a simplistic form where it equals 0, so I then can factor, and then I can then add what the roots are going to be together. Okay, so what is the sum of solutions? So here I have x squared minus 14x plus 40 equals 2x plus 1. I'm going to subtract 1 on both sides, subtract 1 here, and then I get x squared minus 15x, and oh, what am I doing? So this is minus 1 here. Sorry about that. So not 15x. It's minus 39, but this is actually going to be subtracted, so it's going to give me a minus. So I do minus 2x here, which is also minus 2x here. So this gives me minus, yeah, okay, that's more favorable because I'm already doing multiples in my head of like things I can factor for. So x squared minus 16x, and then it's plus 39, which also works, equals 0. Now, why do I like the negative and why do I like the positive? Because when I factor two things relatively quickly, something I want to pay attention to is what two things, when multiplied together, give me positive 39, but when added together will give me a negative 16. Now, the only two things that I can think of just readily off the top of my head that will give me a positive 39, other than 1 and 39, are actually 3 and 13. So if I do x minus 3 and then x minus 13 here, right, then when I multiply these together, right, negative 3 times negative 13, that will give me a positive 39. But when I actually FOIL this out, I will get a like term of negative 16, right, when I add them together. So my answers here are, it's actually, if I have to solve for the solutions, then I have to set all this equal to 0, which means that this becomes x minus 3 equals 0, and this becomes x minus 13 equals 0. And if that's the case, then this becomes x equals positive 3, and then x equals positive 13. Although realistically, I wouldn't be writing this down in the test. I would do that in my head. And then I would say, okay, well, what is the sum? I remember I always go back and I circle the thing that essentially I need to find so I don't make a little mistake. Because these questions aren't impossible. I just want to make sure that that if I know actually how to do the math and I know what to do and I know the strategy and such, I don't make a careless mistake of knowing what to do. So it should be positive 16 for, so here, this, first of all, whenever you see a bunch of stuff here and you see an equation up top for like number 14, 9 out of 10 times, this is going to be some sort of what they call literal equation problem, which means they are going to make you do like fancy algebraic math in order to solve for everything in some capacity, which means I also want to go and I want to skim my answer choices, V, right? So without, let's pretend I can't even read, right? Without even reading English in terms of what the problem is, what I know I need to do is somehow solve for V, right? That's the idea. Now, I can go and read all of this, and then it says when the formula above expresses L in terms of S, V, C, speed of light, which defined as speed, yep, and the object in terms. So I'm only reading this last part, even though I sort of knew what to anticipate, because of the fact that I just want to make sure, but all my answer choices kind of reflect the fact that I have to solve for V. So quick tip is that this question is supposed to take up a lot of time for you because it wants you to look at it, and then wants you to read everything, and then it wants you to sort of decipher what to do. I, on the other hand, I'm gonna basically, and I'm even gonna go to a different screen because I don't know how much writing I'm gonna have to exactly do. But here it's L equals S. So here I have L equals, and it looks like S, and then it's a radical 1 minus, okay. And then this is radical, and then it's 1 minus B squared over C squared. Okay, just trying not to make a mistake, right off the bat, right? It's usually easier right on the test because then you can sort of like scribble and have it for what you have. Okay, so L equals S radical 1 minus V squared over C squared. Now remember, once again, we are trying to get V. We're trying to get V by itself. And if I get stuck on anything, I'm gonna go back to my answer choices so I can sort of guide myself to figure out, okay, well, what did they do? Maybe what are some steps that they took in what particular order? First thing I noticed is that these are being multiplied by each other, and I want to get V, but the V is under the radical, so I need to divide everything by S, okay? And so I want to go back to my answer choices real fast to be like, oh, they did L squared over S squared, right? So in some way so this is good. This is a good step, right? Notice what I'm doing. I'm sort of like guiding myself. If you need to do that for whatever reason. So now the S's will cancel, and I'll draw a little arrow so you guys can see the steps. Here I have LS equals radical 1 minus V squared over C squared. So now I need to get rid of the radical so that way I can get V by itself. So I'm going to square root everything, right? This is technically, I guess, step 2, right? Which means I have to square the other side, right? Now, when I do this, I get rid of my radical, which I now get 1 minus V squared over C squared. And I'm even going to simplify this. This becomes L squared over S squared. Now, if you need to, go back to your answer choices to help guide you to see if whether or not this is an actual step, okay? It is, right, because you're going to see it. And one other quick tip, if it doesn't have a minus in here now, like if there's no minus, I'm probably not going to choose that answer choice if heaven forbid I get stuck with something. And why? Because of the fact that this is a 1 minus this, right? So I'm probably leaning more towards the other one. So here I go, and so this is what I have, which means I now have to bring this minus over here. So I'm going to do L squared over S squared. And I'm going to minus 1, right, on both sides. And then this will equal minus V squared over C squared. Remember, the minus stays for this side. Oh, sorry, didn't mean to do that. So the minus will stay, and I simply subtracted the -1 over to the other side, which is what I get here, okay? And now I want to get V by itself. So I'm actually, you know what I'm gonna do? Is I wanna get rid of this negative first. And there's more than one way to do this. Because I wanna get rid of this negative, I'm going to multiply the entire thing by a -1, okay? And all that's going to happen is that these are going to flip, right? This is then going to become, because the -1 times the -1 becomes a +1, but this is a negative. So this will actually become negative L, right, over S squared, right, and then like +1. So you can rearrange these, which is probably what they will do, to become 1 minus L squared over S squared. All right, so, and then this on the other side, and the reason why I did this was because I wanted a positive C squared. Now I can do it at this step, or I can do it at a different step, whatever is easiest for you. Okay, so now I need to get rid of C squared. So I'm gonna cross multiply, right? Or basically multiply by the reciprocal for C squared. But I have to do C squared for the full thing. So this becomes C squared here, and then already ran out of room, right? These cancel. And then now here I have V squared. So I'm gonna go back, take a quick screenshot if you need to, and I'm gonna start deleting certain things. It looks as though that this becomes C squared, and then this, oh, okay. So let me see. Oh, I know why. So I do leave it in this form, okay? So I don't distribute, right? And the distribute is, if I would look here, right? I don't want to go the extra step. So I was doing it the right way. So here I have V squared, right? And then when I take a radical to all of this and all of this, so that way I end up getting, but see what I did? I sort of got a little bit stuck. I went back and used my answer choices to see if I should distribute this. I noticed that there's no C squared and another C squared. Instead, I went back to my answer choices and said, okay, they keep the 1. And because of the fact that they keep the 1, I don't want to do that step, right? So that sort of helped me in terms of guiding me what I do for my answer choices. And then I do the radical here, which is over all of this. I know this problem is oh so fun. Minus 11 or L squared over S squared, right? And then equals V, right? Because this will simplify to become V. So this should be my answer choice here. Odds are they will simplify this, which they do in the answers, to become C. And then this simplifies to be a radical here, which is radical, and then this becomes 1 minus, right, L squared over S squared. So they keep this under the radical, and they bring the C out because of the fact that it's being squared of a radical. So I think that that is my best answer choice, which is why I was leaning towards A. But notice what I quickly did. I kept the minus sign. I knew I would have to do a radical, and that's why I did the C. So that's why I was leaning towards C, or leaning towards A, because I knew that my C squared would go away, right? If I did the radical, right? So if I got stuck, I sort of solved it through. So feel free to take a quick screenshot of all of this, or if you have any individual questions, you're more than welcome to kind of send me a quick email, right? And for this particular problem, the best answer is going to be A, okay? So for 15, it says here, the half-life of a certain substance in an aquatic environment is about 150 years is referring to my half-life, which is following experiments, functions, best models, the amount of A of T in grams of substance T years after 200 grams. So 200 is my initial, right? So this is my initial, which means it's going to be multiplied by something. And it says, substance applied to it. It says the following functions best models the amount of grams and the half-life. Okay, so the half-life is when after a certain amount of time takes place, literally half of that substance will decay within nature. So that's where the 1/2 is coming from. The 200 is acting as your initial. So it's going to be either C or D, because here the 200 is acting as the amount, whereas the 150 is acting as the actual half-life. They're referring to, it says the half-life is the length of the time needed for an amount of substance to decrease to 1/2. And what they want to know is which of the following experimental functions best models the amount of A of T in grams of the substance T years after 200 grams of the substance applied. Well, if I want one half-life, right? If in that instance to occur, if I want one half-life to occur, then it would happen at 150 years, right? So if it's at 150 years, let's just pretend I have 150 years that happens, then I will experience, right? This would be, right? If it's like T of 150 years, right? Then this would give me one half-life here, right? This would then be like 1/2 to the power of 1, which would be one official half-life for that substance. So I'm liking D, right? And the reason I'm liking D is because that is my initial amount, and my 150 over my 150, if I put this as my actual time or my increment here, then that would simplify to be 1. And if this is 1, then it's 200 times 1/2, which would give me exactly 100, which is half-life. Right? And that's the half-life is the length of the time needed to amount of substance to decrease. If you plug in numbers in any other one of these, they won't work. The first hint that you should take, though, is what is your initial value. You should sort of analyze where do the numbers come from, why are they putting them there, in what respect. So you should get rid of A and B, right? Because your initial amount will not be connected to the half-life in terms of an exponential form. The exponent will be connected to the actual half-life. It won't be connected to the initial amount. Okay, so D is most likely going to be my answer. So let's slide. Oh, now, okay, good. We're in the open-ended. We're almost there, right? It's good because now the questions are going to repeat. They're going to get a little bit easier. So hopefully they won't take nearly as long as question 14. Okay, so the graph of y equals mx plus b, where m and b are constant, showing the xy plane. What is the value of m? So remember, m is your slope. And because of the fact that they're actually giving you coordinates that you can see here, what I would say is you always want to do the principle of your rise over your run, because it's always faster. So I'm simply going to count. I do want to pay attention to my increments. These are all increments of 1, right? These are also all increments of 1. Sometimes they will hit you with different. They will do like increment of 3 versus an increment of 1. Just want to pay attention to that so you don't make a common error. So this goes up. Let's say, what does it go? It looks like it goes up 2, and it goes over 1. I'm going to double check. It goes up 2, goes over 1. Yep. So it's going to be 2 over 1, which my slope will then be 2. You can also, if heaven forbid you need to solve for b, just plug right the 0 in for x in order to get it equal y. And this is usually right the fastest way to kind of like when x is 0, right? What is y? So be prepared for either way that they would essentially ask the question. Okay. For 17, x plus y equals 5, 2x equals 5. This is immediately the first thing you should realize. These are stacked. Because these are stacked, it's most likely a systems of equations problem. And I'm going to circle the thing that they want me to find. You can either use elimination or you can use substitution. I'm actually going, because of the fact that they want me to find y, actually you can use either. I don't think there's an immediate faster way to do one or the other. But I'm probably going to do substitution, where I'm going to make this equal to x equals 5 over 2, right? So you notice what I did here? And now I'm going to substitute this x into here, which I then get 5 over 2, and then plus y equals 5. And then now I'm going to subtract. So the reason I normally don't do this is because there's usually coefficients out in front. It makes it more complicated. But in this instance, because I'm just solving for y, I'm just going to subtract 5 over 2 from this side. So this becomes 5 minus 5 over 2, right? And then this is y. So now I need to find the common denominator. So here I get y equals, and this is going to become 10 over 2, which would give me 5. Remember, the common denominator in this case is 2, and this actually gives me 5 over 2, right? So that's, sorry, 5 over 2, not 5 over 5. And so 5 over 2 should be my answer choice. So they will either accept this, or if you simplify it, they will accept this, right, for 2.5. But there's no a lot of times your answers won't be in decimals in section 3, and the simple reason for that is you don't have a calculator. So a lot of times it's usually faster to work with fractions than it is to somehow convert that fraction to a decimal and like do the extra step. So just be mindful. Also, my answer isn't negative, which answers are not negative and open-ended. You don't have actual radical signs, and you also don't have pi, right? So those are the 3 things to keep in mind. But the biggest misconception is that you don't have negative answer, right? You actually don't have negative answers. So I like the fact that it's positive. I like that it works out. I can solve it the other way if I want to really check, but I'm pretty confident the answer is 5 over 2, right? Or 2/5. So, okay, so a couple more questions, and then we'll sort of finish up for today. Okay, so what positive value of x satisfies the equation above? So what positive value of x satisfies? Now, I notice here there's a 0, which means I need to figure out what factors or what roots go into this. So if this is x and then minus 3, and then this is plus 1, right, 0. Remember, as we're sort of coming to the home stretch, if you guys have any general questions or want me to sort of go back to any of the other questions, just let me know. In order for this to become equal to 0, then this has to be equals plus 3, right? If I insert a plus 3 here. And this has to be minus, or x equals minus 1. And this would have to be 0, right? So it's saying what positive value of x, so 3 is going to be my answer choice, and not negative 1, right? Negative 1 plus 1 gives me 0. 0 times anything else would give me 0. So 3 is going to be my answer for this. All right, what value of x satisfies the equation above? Now, remember what I said in terms of decimals, all right? So sometimes they can get a little tricky. If you forget the rules, whatever. In that instance, I would always say do your best to sort of like convert it to fractions. And if you ever get stuck, multiplying by 10 is usually a quick hint. And here's what I mean by that. So here I have 3x minus 0.6 equals 1.8, okay? I'm gonna add the 0.6 on both sides, right? So here's 0.6, add it. Hopefully you know that 18 plus 6 gives me 24. So therefore, because of the way that the decimals are positioned, that you know this is 2.4, right? And so now if I have 3x equals 2.4, and if you get stuck where you're like, how do I do 2.4 divided by 3? What I would probably suggest is multiply the entire thing by 10, so that way you're working in bigger numbers that you're probably more familiar with. So if I do the entire thing here by 10, right, I'm getting it out of, and in this case, it's because I'm getting out of the tens place of it. Now, you don't need to do this every time. Hopefully you also feel comfortable doing some decimals in most instances. But if you ever feel stuck, like, hey, what are the exact decimal placements of the rule, then multiply by 10 in order to get rid of the actual decimal, and then simplify within the fraction form. So here it becomes 30x equals 24. Right? Now I'm going to divide, and what I'll end up getting is x equals 24 over 30. And now I can simplify, right? It's easier for you guys probably to simplify 24 over 30 than it is for you to simplify 2.4 over 3. And So if I do 24 over 30, these are both, right? What's my common multiple between them? Looks like it to be 6. So if I divide this by 6, I get 4. If I divide this by 6, I get 5. So my answer will be 4/5. And that is acceptable. So I'm good if I want to keep it in that particular form. If not, I can convert it back to decimal if I feel comfortable doing that, okay? So here we are kind of in the home stretch. And okay, of course they would. All right, so this question says, let's see, I haven't done or looked at. Square is inscribed in a circle with a radius. Now, whenever they're giving you this, they say that, oh, actually I started to draw incorrectly. Whenever they say inscribed in, right, it means that's the shape that's inside of the other shape, right? So when they say in a circle, that means that I first want to draw the circle, and then the square is inscribed in the circle, okay, for what I have here. So this is what I mean by inscribed in. And it doesn't need to be perfect. You just honestly need to make sure that you can sort of line up the points. And when they say inscribed, it means the points should be touching, okay? I'm gonna choose a different ink so you guys can sort of see the rest, right? And then it says with a radius. Now the reason why they're giving you this is because any point to the outside of the circle, and I'm purposely choosing 2 other parts here, that is what is defined as my radius. And it says each one of these, so if I notice I'm going to the points of the square that also touch the circle, right? I'm purposely choosing those points. I could have chosen any point, right, on the circle to go to the outside, right, like this, but that doesn't help me as much as knowing the type of problem that this is. It then says, what is the perimeter of the square? So I want to circle this so I don't make a common mistake of solving for area or something else. And the perimeter is 2 times the length plus 2 times the width, right? Or in general for a square, since they're all the same side, to make it easier for you, it's 4 times s, right? So theoretically, if I solve for one of these sides, now hang in there for it's 5 o'clock right now, but hang in and I'll finish up this problem and sort of, and if there's any other problems at all that you guys want to do, just let me know. Theoretically, because these are both radii, and because this is actually creating like a perpendicular angle, which is 90 degrees, now I told you they love themselves some triangles, right? That happen. So this is 6√2, and this is 6√2. But notice what I just formed across from the right triangle, right? I just formed a hypotenuse, right? That's what's across from my 2 sides here. And I can do it for any side. It doesn't matter which side of the square I pick, right? So I just chose this side and I chose this other side here, right? Just plug them in so you guys can see it. Because what I theoretically want to do is I want to somehow solve for one of these sides. Because if I can solve for one of the sides, then therefore I can multiply it by 4 in order to get the total perimeter of the square. So how can I solve for the side, knowing now that I have a right triangle and knowing that I have 2 sides of that right triangle? Well, like any right triangle, right? And notice I'm drawing them in different formations, but it really doesn't change the mathematics of it, is that I have my a squared and I have my b squared and I have my c squared, right? Because of the fact that I was able to decipher the fact that I have a right angle within it. So if I take these values, if I square those values and then I add them together, and then I take the radical of that value, that is where I will get c squared, right? Because these are, and it's just arbitrarily defined whichever one you want to make a squared and whichever one you want to make b squared. So I'm going to do that over here. I'm going to do a squared plus b squared equals c squared. And I'm going to do 6√2. And remember to do squared, right? And plus, and this is the same, 6√2. And then also squared. And then this is going to equal c squared. Okay? And this, now, the hardest part probably about this problem after you decipher everything is knowing what do I do with the square. And I hope you remember in terms of exponent rules that it goes to both, right? It goes to both things when you have a radical here. So this becomes 6 times 6, which is 36, but then this becomes radical 2 times radical 2, which is 2. So this becomes 36 times 2, which is 72. And I like this. I'm going to tell you why. Because I do this again, which is the exact same value, right? 36 times 2 plus 36 times 2. And then this is going to be 72. And 72 plus 72, what would you know, is 144. And 144 in terms of c squared is going to be 12. So every one of my c squareds, right, or every one of my c's, is going to multiply by 4 in order to get my total perimeter. So I have 12, 12, 12, and 12. So this becomes, right, so this becomes 12 times 4, or 12 plus 12 plus 12, which is total perimeter. So my answer is going to be 48, right? Perimeter will equal 48. Heaven forbid if they ask you what the area is, then that's length times width. That will be 144. Notice this is a combination of a lot of different ideas. It's a combination of circles. It's a combination of radicals and exponents. It's a combination of Pythagorean theorem, right? It's a combination of special right triangles to identify the fact that you form a right triangle. So I understand why this is probably question 20, even though it's not impossible. It's just there's a lot of different layers to it of knowing what to do. But quick tip is that whenever they give you something inscribed in something, just make sure that you draw it appropriately. Like in this instance, I made sure to touch the square to the outside, right? And that's what I was paying attention to. So if you have questions about why I drew it in that manner, it was simply because of the fact that I knew that if they give me the radius, that would sort of lend on the radius, right? And I can solve for other parts. So whenever you have something inscribed, a lot of times you're actually going to end up doing a triangle in some capacity. Most of them lean on triangles. Okay, so that is where we are for today. If you guys have any individual questions at all, and we'll be posting future webinars in terms of doing for section 4, so I'll make sure to keep you posted. Notice that a lot of these questions, as I was sort of going through them and making sure you guys had a pretty good understanding, a lot of the questions didn't really require a lot of writing. I wrote it to sort of illustrate to you kind of the concepts that were involved, but for the most part, you want to try to minimize the amount of writing that you're doing by understanding what they're really looking for the most part. And some of the questions I wouldn't have had to write anything at all, and if I just wanted to check. So my advice to you would be to, as you're attempting every single question, make sure you can identify the concepts, what is given, and essentially how it relates. And sometimes your answer choices are a huge hint of identifying what they're giving you and how to go back and solve the problem, and even sort of guiding you as you're doing a really long problem, like when we did number 14, right? There were a lot of steps that were involved and a lot of little things. So we were checking back within the answer choices. But that is all for today. I will keep you guys posted on future webinars. If you have any questions at all, once again, I'm Anthony Weinkopff from Embrace Human Educational Services. If you have any questions, you're more than welcome to send me a quick email within the chat feature that I've provided. But if there's anything we can do more for you guys, just let me know, okay? All right, guys, it has been a pleasure, and please let me know if you need anything at all. All right, take care.